Okay, so we're going to start our video lesson. It's actually going to be from 7.2 as well. So I'm going to put 7.2/7.3 because I want to talk about how to transform, let's just say, the model. I want to go ahead and speak about how we're going to use the example from today, which was g of x is equal to 2x plus 5 over x plus 2, and be able to change how we look at this equation. In class today, what we ended up doing was we ended up doing the three-step process in graphing a rational expression, and that is, or a rational function. And that is, number one, we found the horizontal and the vertical asymptote, and we graphed that. And then we also found a couple points, plotted those, and then we drew in the branches. Now, when we were graphing it, you can kind of see where the branches make out. It was helpful when we added the asymptotes, but you'll notice that the asymptotes obviously were transformed. They were translated. We were able to find a vertical asymptote at -2 and a horizontal asymptote at 2. I think that was the case. So the question is, if we have the same equation and we graphed it directly using the asymptotes, is there a way that we can change it to reflect perhaps a different way this function can look like so that we can get a better sense of the asymptotes? And the answer is yes, because if you think about a ratio, which we talked about today, it's the numerator divided by the denominator. In other words, it's the polynomial divided by this binomial. So in this case, we have a binomial divided by a binomial. So do we know how to take a polynomial and divide it by another polynomial? Yes, we do. We actually know, so in other words, we know that this is just equal to 2x plus 5 divided by x plus 2, okay? And in this case, because our divisor is x plus 2, we have two options. We can either use long division or we can use synthetic division, which we learned about a while ago, okay? So let's just say for, just in general, in case not all of these are binomials, let's just use long division, which is an overall blanket way of dividing polynomials. So we have 2x plus 5 divided by x plus 2. So how we did it before was we asked ourselves, what do I have to put here so that I can multiply x and get 2x? Well, the answer is 2, because 2 times 2x is 2x, and then 2 times 2 is 4. We're going to subtract this out. These cancel out, and we get 5 minus 4, which is 1. Okay? So in this case, our remainder is 1. Okay? And so the remainder, remember, we use the remainder by adding it to this value. Adding it to this value up here and putting it over the divisor. Okay? So our answer, in fact, g of x is equal to 2x plus 5 over x plus 2, can be rewritten as g of x is equal to 2 plus 1 over x plus 2. Now, this doesn't look quite much like what we've seen before, but if we use the commutative property, we can rewrite this as g of x is equal to 1 over x plus 2 plus 2. All right? And here we have to stop and say, well, this kind of looks like the other model that we had on the board, which is a over x minus h plus k. So if you notice that this matches the model, this case we have x minus -2, okay? So our h is -2 and our k is 2. So this is basically our basic graph that we did in our video lesson a while ago, which is g of y is equal to 1 over x, except it's been shifted over by 2 to the left and shifted up by 2 up. So now we can graph it, all right, just by knowing that information. And so our final result will be, all right, our original asymptote, which was at 0, 0, is now shifted 2 units to the left. So we're going to shift our the original vertical and horizontal asymptote are at 0, 0. So essentially we're shifting the vertical asymptote by 2, and we're shifting a horizontal asymptote by 2. Okay? So, and now when we plug in the branches, we will be able to see that our graph, I think, if it matches earlier, it looks something like this, okay, which is y is equal to 1 over x, or g of x is equal to 1 over x. So the branches in the upper right and the lower left. So that's how you can also look at a rational function in this kind of h and k format, just by doing division in between.